Okay, so in our last video, we wrote a fairly simple program here in Python using the turtle module, and in that program we had a turtle creating a square. So this was the code that we used for that particular program, and as you look back at this code, you'll see that we had a lot of statements here that were repeated. So we had this forward statement, so moving the turtle forward by 100 pixels, and then turning left by 90 degrees, and then repeating those things 3 more times. So if you're thinking that there may be a better way to go about writing this, you're absolutely right. So most programming languages provide some sort of syntactic structure to repeat some set of instructions some number of times. And we call these structures repetition or looping structures. And by using these particular structures, we can save on the number of lines of code that we would have to write. And this turns out to improve readability and also makes our programs less error prone. So you can imagine here, if we were to do a repetition of these same instructions of forward and left, maybe 100 times, that's a lot of code that we'd have to generate. And the more code that we're generating, the more likely we are to make mistakes. And it also makes it more difficult to read because people would have to go through and actually look at all those lines of code. So in Python, as in other languages, there are a few different kinds of repetition structures, but for our video today, we're going to only look at one type of repetition structure. And that particular repetition structure is called the for loop. And the for loop is designed for what we call definite repetition or counter control repetition. And what that means is we know exactly how many times we want to execute some particular instruction or some set of instructions. So let me just show you the syntax in Python for constructing a for loop. So it looks like this, and this isn't syntax that we can actually run, but it's the generic structure. So it has this keyword for, and then I'm going to use these angle brackets to sort of denote generically what's supposed to go there. So in this first one we'll have an index, and I'll explain what the index is in just a sec, and then we'd have this word in, that's another keyword in Python, and then we'd specify a particular sequence here. Again, this isn't a keyword, this is just specifying what we'd have generically there. And then we'd have a colon, and then below this we would have all the instructions, or maybe it's just a single instruction that we wanted to repeat some number of times. So here we would have our actual instructions. So this sequence here could be of any particular size. So we could have 50, 4, 100, it doesn't really matter. And this index here allows us to what's called iterate over the sequence. So it's able to take on various values, so 0, 1, 2, 3, whatever it may be. In computer science, we typically start at 0. So let me go and change this here to actual valid Python syntax. I'm going to say for I, that's going to be the name of our index, and then I'm going to say this keyword range. So this is actually a function, and I'm going to put it in open paren, and then for, and then close paren. And then down below here, we'll specify some particular instruction. So the instruction that I'm going to have associated with this particular for loop structure is just a print statement. So we'll do print, and then do double quote, and write the word turtle, and then another double quote. So there's a reason why I put turtle inside of double quotes is for us to create what's called a string. And a string is just simply a sequence, or it can be a sequence of characters. We can actually have what's called an empty string in which we have no characters. We just have a double quote and then another double quote. But don't worry too much about those details just yet. What I want you to be comfortable with is the idea is that we created what's called a looping structure here using a for loop syntax, and we're allowed to repeat some set of instructions. In this particular case, we're going to repeat this particular instruction, print turtle, 4 times. And notice also that this instruction has been tabbed over. Whenever we come down from this particular line here and hit enter, it automatically tabs us over. So it's expecting us to write some particular instruction that's going to be associated with this for loop. So we could have multiple lines of code associated with this for loop, and each one of those lines of code would be executed 4 times in sequence, assuming that they've all been tabbed over. So if they're not actually tabbed over, then it's not going to be associated with the for loop. So let's go back and just type in print, and then the word turtle there in double quotes, and save this, and then run it. So you can see that our turtle drew the square, and we have the word turtle printed out 4 times. If we wanted to, we could have the value of I being printed out. So I, once again, is just our index value, and it's iterating over whatever values that we have here in this range. So let me just print out the value of I, and we'll run this again. We'll see our turtle doing a square again, and we see over here that we have the values 0, 1, 2, and 3 being printed out. So behind the scenes, what's really going on is we have this list being specified of 0, 1, 2, 3, and then a closed square bracket here. So that's really what's going on whenever we specify range, open parentheses 4, close parentheses. It's just a quicker way to write the same thing, especially if we had a very long list. So we could do range, open paren, 100, close paren, and it would have the values between 0 and 99. So that's really what's going on there. And each one of these particular values here has a particular position, and I is just iterating over all those values, or moving or traversing through all of those values. So we can run this again and see that we get the exact same output that we had before. So we go to our turtle moving around, making the square, and we get the values of 0, 1, 2, and 3 being printed out. So now that we have this idea here, we can make use of this for loop structure to repeat some of these statements here. So to repeat the left and the forward 4 times. So what am I going to do is take 2 of these lines of code that has the forward and the left instructions, and take them out there and place them here where we have our for loop. And I'll go back and do our original syntax where we're using the range syntax, since that's more commonly used than actually specifying a particular list. And you'll learn about lists a little bit later. So we'll do range, open parentheses, for, close parentheses, and we'll also get rid of all this other business. So now we have conceptually the same program, but a lot less code. But it should do the exact same thing, because we're still going to be doing this move forward and then turn left and do that 4 times. So let's go ahead and save this and see if it actually runs in the same way. So we can see that our turtle is still making our square. Of course, we got rid of the code there that we were printing out, the values over here on the console. But the main thing behind doing all that was so that we could have a structure in which we would do the same set of operations, but not have to type as much code in. So that's the for loop. And hopefully you have a better understanding of the idea of a looping structure. And there's other looping structures supported in Python, and there's also other syntax just associated with a for loop, but we'll look at those maybe in some other videos. Okay, so let me pose a question. Say that we wanted to be able to create multiple squares just like this in our program, or maybe in some other program. Do you think we would need to go in and copy this code and just paste it in wherever we wanted to generate a square? And you're probably thinking, well, probably not. There's probably a better way to do that. And you're absolutely right. We don't have to go in and copy and paste this code every single time we want to create a square which has a side of 100, or the length of the sides is 100. So most languages, including Python, allow us to group together some set of instructions that perform some well-defined tasks, just like we have here, some set of instructions that define the task of creating a square and provide a name for those things. So the named set of instructions, or these named set of instructions that we can have for some well-defined task, is what we call, sometimes a function, sometimes a procedure, sometimes a method. It really depends on the language that we're using, or the programming paradigm, or what that thing is actually doing, which term we actually use. So don't get bogged down in the terminology in terms of function, procedure, or method, and which time we use which name. Just understand that those are the general concepts, or the general names that we can apply to this concept, grouping some set of instructions together, rather, to perform some specific task. So what we're going to do is create a procedure. I'm going to use the term procedure for us in this particular case because I think it's the right term, to draw a square. And we already have the code to draw a square, so really all we need to do is provide some additional Python syntax for creating a procedure. So the way we go about doing that is using the keyword def. So that's defining something, and we want to define a procedure for drawing a square. So I'm going to call it, or name it. So the very next thing we had to do was name it. So draw underscore square, and then open paren, and then close paren, and then a colon. So what that does is it specifies just simply a procedure named draw square, and all the instructions that are associated with that have to be tabbed over. So the very first instruction should be tabbed over, and then since we had these instructions for forward and left associated with the for loop, they have to be tabbed over as well. So now we have a procedure here to draw a square. So anytime we want to draw a square, we can just call that particular procedure. And the way we go about calling a procedure is just simply specifying the name. So we can say draw underscore square, open paren, close paren, and that's it. Now, these parentheses here can be used to actually pass information in to a particular procedure. In our case, we didn't specify any particular set of parameters inside of those open parens, close parens, but we could actually specify multiple parameters there if we wanted to. As it is now, we don't have any mechanism to actually pass any information into this procedure. So let me go ahead and save this and then run it and see what happens. So you can see that our turtle drew the square just like it did before. So what's actually occurring here is we're executing these statements that we have at the very beginning. So we're importing the turtle module, we're creating our turtle, and we have this variable t associated with our turtle, and then we're specifying the shape to be of the turtle shape as opposed to the default arrow. And then it's not executing this straight away. What's happening is it's actually executing this draw square, which ends up calling this particular procedure here, called draw square, and executing these statements. So that is what's going on. And if we wanted to, we could actually invoke this draw square procedure as many times as we like. So I could say draw underscore square, open paren, close paren, and click on save, and run this particular program again, and we should see the turtle go around twice. And he does go around twice, or her, or it, whatever you want to say. And you can imagine that we could also apply looping structures to drawing a square. So if we wanted to repeat drawing a square, we could wrap this up into a for loop structure. So we could say for I in range, and we could say maybe 5, and then do colon, and then do our draw square. Make sure that's tabbed over so it's associated with that. So now we're going to execute this particular instruction here, which is calling this particular procedure 5 times. So I'm going to click on save and click on run again, and you'll see the turtle goes around 5 times. So that's a pretty neat thing, that we can combine these concepts together and start constructing larger and larger programs. Let me just show you an example of what we could do in terms of, I'm going to get rid of our for loop for right now just to simplify things. And say that we wanted to draw a square of a particular size. Well, what we can do is specify the size here. So maybe we want to specify a size of 100. And we'll go back here to our draw square, and we'll specify a particular name. So we could say size or length. Maybe length is a better name here. So the length of our sides for our square. And we can make use of this. So this is a variable, and this variable is going to take on whatever value is passed to it. So whenever we execute this draw square line of code, it goes up here and executes this, but it's also passing this value here to this length. So the length now holds the value of 100, and any time in our program where we have this variable length, it's just going to substitute in the value of 100 in this case. And we could do the same thing again. So if we wanted to, let's do another draw square. And this time we'll pass in the value of 50 and see what happens. So let's go ahead and save this and run our program again. So it drew the square of size 100, and then it drew another square of size 50 inside of that square. So that's a pretty powerful concept. What we've done now is parameterize this code. So one of the reasons that we write a procedure or a method or a function is so that we can reuse code, but also so we can parameterize that particular code. And it also turns out easier to debug. It simplifies us in terms of writing code and being able to debug the code. But we now have it in a much more generic fashion where we can create a square of any particular size, whatever it may be. So let me, just for the sake of creating something new and different, we'll create one more square. And we'll say that this square is going to be of size 200. So since we went to 50, we'll go to twice the original size and go to 200. And we'll run this one more time. All right, so you see that our little turtle there drew our 3 squares, one of size 100, or that has a length of its sides being 100, this one having a length of its sides being 50, and this outer one having the length of the sides being 200. So that pretty much covers everything that I wanted to discuss in this particular video. So we looked at this idea of repetition, being able to repeat some set of instructions, and we also looked at this big concept of writing procedures, so being able to group some set of instructions together and apply a name to them. This allows for code reuse, it allows for simplifying the problem, easier to debug, which is just troubleshooting our code if we have any sort of issues, and also being able to parameterize our code, being able to pass in different values. So that's it for this particular video, and we'll be doing some more cool stuff in our next video.